My name is Michael Gianarakis. As Pat mentioned, I manage the Spider Labs team for APAC, and I do application security. So that's about it. Let's keep going. So what's this presentation about? So I wanted to give like a quick and dirty introduction to runtime hacking on iOS to help people get up to speed quickly. Awesome, cool. I've worked with a lot of people over the years and sort of helped get them up to speed on iOS testing. And the runtime hacking stuff is where most people get sort of caught out. So I want to provide some kind of practical tips. So even if you don't fully understand it, you can kind of, be a bit dangerous. I'm going to focus on third-party apps. So, no elite iOS O days today, sorry. What it's not, I'm not going to talk about things like data security, transport security, very important things for mobile security in general, especially on iOS. But like testing data security, it's kind of like navigating a file system. So, you should all be able to do that, hopefully. I won't really touch on remediation or anything like that, simply because I don't have the time. But I do have some other presentations at that link there around like iOS pen testing more broadly and how to secure apps. So I'll run very quickly through like Objective-C basics and setting up the environment. Then the meat of the presentation is going to be around like mapping out the application, dumping and modifying variables, manipulating functions at runtime, and just a brief touch on how this may be affected by Swift. Cool, Objective-C basics. So native iOS applications are written in Objective-C, more recently also Swift and C, I suppose, C++. Objective-C is a superset of C. A lot of people kind of get scared off by Objective-C. It looks a little bit weird. But really, if you know C, it shouldn't be that scary. It's basically C with a bit of sort of small talk style, like messaging and object syntax. So there's interface and implementation files, much like C. They don't need to be in separate files, but the common sort of, approach is to put them in separate files. I'll just run through this very quickly because I'll do some more practical stuff later on. But you've got interface, class, superclass, class methods. They start with a plus, a return type, parameters separated by colons, and their types. Pretty straightforward. And instance methods are the same, except with a minus in front of it. And then the implementation kind of looks like that. I'll go through this in a little bit more detail when we get on to mapping out the application. Calling methods in Objective-C, basically like that. You've got your object, method, and then your arguments separated by colons, and terminated with a semicolon. Important takeaways, so like the absolute basics, if you can just understand like basic OO principles, things like inheritance, difference between like a class method and an instance method, then you can do some pretty cool stuff. A rudimentary understanding of MVC, and by rudimentary I mean like super simple, model, data, view, presentation, controller, logic. That's super simplified, but that's kind of all you need to know. And super basic Objective-C. How to call methods, embrace the square brackets, don't be afraid of them, and how to read and write variables. So you don't need to know that much to kind of be a bit dangerous. So setting up the environment, I'm not going to go into too much detail on this, just a list of different tools that we'll run through, and I'll run through how to use these throughout the talk. I do have like a slightly outdated guide up there on my blog that covers setting up most of this stuff. Cool. So mapping out the application. So it's the most important part. Obviously, for any application kind of testing or network testing, doing your reconnaissance and understanding how things work is definitely important. Objective-C apps store a bunch of useful runtime information in the executable, which really helps us out a lot. It can provide like great insight into how the application functions, and obviously that has security implications. It's great for helping us find bugs. So apps that you download from the App Store are protected with the Fair Play DRM, and basically that means certain portions of the binary are encrypted. If you want to do analysis in the tools, as I'll demonstrate, you need to decrypt these portions before you can analyze it. You do it manually, extracting the encrypted portion after the loader decrypts it, and you can patch it into the binary. But there's heaps of tools out there to automate it. So Dump Decrypted by Stefan Esser, Clutch, Rastercrack. I recommend you just use those. It's nice and easy. I'm not going to demonstrate this. There's plenty of guides on the web to do manually and also using the automated tools. But just to note that piracy is not cool, so don't use it to pirate apps. So obtaining a class dump. So as I mentioned, the binary stores a whole bunch of runtime information, methods, instance variables, things like that. And with the class dump Z tool, you can basically output what is essentially the equivalent of an Objective-C header file. So that's the command there. Those options are just kind of like formatting options, so things that I like. You don't need it, but putting things in alphabetical order, sorting the class methods before the instance methods, things like that. And then go to the binary. So I'll do an example. See how we go. The screen resolution's bad. All right. Can you guys see that all right, or do you want me to make it a bit bigger? Is that cool? So I've already grabbed the binary and decrypted it. So I'm just going to use Evernote. And so class dump. Is it Evernote, and I'm just going to dump it out into a file called Evernote dump. So run that and fire it up in your favorite text editor. And the great thing about this is you can even use syntax highlighting. It's that sort of similar. Cool. So what you see is a bunch of information. You've got some type definitions. There's a heap. It can be quite big. It includes everything that was in the binary. So your classes, libraries, things like that. We can pull out. Let's just pick a class. So here we've got a EN notes map view controller, which has unknown superclass. You'll see that a lot with class dump C. It can't sort of tell superclass. Honestly, don't really know why that is. It's usually not a big deal. And here in the angled brackets are the protocols that class conforms to. And you'll notice, again, trying to give some sort of tips to decoding this, quick and easy sort of practical tools. Things like the EN, that's a class prefix. Obviously that stands for Evernote. When you're looking through the class dump, if it's got a different prefix than the other classes, it's likely from another library. So then you can kind of use that to figure out what's the classes of the actual app, what are library classes, third-party library classes. Here you've got variables. So you've just got the type and the variable name, and the asterisk means it's a pointer. The property keyword, you can kind of just treat these as variables. All the property keyword does, it was introduced in Objective-C 2. At compile time, it just basically automatically inserts the getter and setter methods. Which you can show in the class dump, but I haven't in my options. And then you've got a whole bunch of the methods. You can see here, these are all instance methods denoted by the minus sign. You've got the return type and the method name, and here you can see things like you've got some parameters in here as well. You'll see ID a lot. ID, which is kind of unique to Apple Objective-C, is kind of like an anything type. That's why you'll see it a lot. It's kind of just used by developers as a sort of anything type. And I guess one of the things you'll notice about Objective-C, a lot of people complain about how verbose it is. And that may be bad if you're a developer, I suppose. But if you're a security guy looking at this, it really helps to figure out what things are doing. You don't even really need to start plugging this into IDA or anything like that to have a general idea of what some of these methods are doing. For example, here you've got display notes with filter object, and it takes in a filter object. Things like that. It should be pretty easy to figure things out. I'll go through sort of some quick things to look for in the class dump as we go through some of the other examples. But yeah, so that's sort of a class dump and what it looks like. Again, just basically an Objective-C header file. This is usually something that we will, refer to a lot on a test, or if you're looking at an application, because it's a good guide to sort of figure out what it does and how to exploit it. Cool. So there are other options, as I mentioned, disassemblers such as IDA or Hopper. They're good for giving a bit more of a low-level insight, and at the moment they're great for Swift binaries because you can't really run it with class dump. There's not the same sort of information. Pure Swift binaries, so class dump doesn't really work. But if you chuck it into IDA or Hopper, OTool, which is included in OS 10, that has basically you're able to extract the same information, just not formatted in a nice way. And then weak class dump is a script extension. We'll discuss script a little bit later, that you can actually run by hooking to the runtime of the app, and you get the same sort of output. So that's great if you can't, for whatever reason, decrypt the app, the actual binary. Cool. So dumping and modifying variables. This is great for retrieving sensitive information. So it's easy to retrieve sensitive information at runtime. So things like credentials, encryption keys, personally identifiable information, sensitive business data, things like that. So again, like trying to focus on like a quick and dirty practical approach. Look at the class dump, grep, search, command F, whatever. And these are just some of the terms I look for. PIN, password, passcode, key, username, credit card, session, things like that. Not really like hardcore hacking. You throw a bunch of these terms at it, see what pops up, and look at the context around it. And then once you sort of figure out what you want to look for, then you can hook into the running application with script and retrieve the information. So script, it has a ridiculous name. It's actually pronounced script. For years, I pronounced it cycrypt. You might actually catch me doing that. It has an even more ridiculous premise, which is, and this is from their website, a programming language designed to blend the barrier between Objective-C and JavaScript. Now that just sounds horrible, right? Like Objective-C and JavaScript together, but it's actually like a really great tool for interrogating and manipulating the runtime of an app. It has a lot of great features, which I'll try and run through as I do some of the more practical examples. So here's an example of retrieving a user's PIN. Now hopefully this crappy AirPlay thing will work. Perfect. You guys can see that all right? Yeah, sweet. All right, so the app we're looking at is Evernote. And part of the premium features is you can set a PIN. I've set the PIN. Actually, we'll find out what it is in a moment. We'll go through that. So again, starting with the class dump, let's kind of figure out what we're looking for. In the interest of time, I know that they use the term passcode. So I just like search in passcode, but you could try PIN, password, whatever. And I find this class here. It's called EVE passcode util. So again, that it's like an Evernote class. It's got the sort of EVE prefix. And immediately some interesting things pop out to me. So you've got user preferences. So that's probably the user preferences object. You've got a string, which is a passcode called passcode. That certainly sounds very interesting. A few other interesting things, account context, should disable passcode after next unlock, things like that. This passcode variable certainly sounds very interesting. So let's see if we can hook into the running app and retrieve that passcode. So I'm just going to SSH into this device. So All right. So one of the great things about Cycrypt is you can hook into the running process just by giving it the name, or you can pass it a PID. Should find Evernote. Great. So now we're hooked into the running app. So you can see we can call the app object. We can call it Stelligate. Great. So let's go find this Eve passcode util object. Now, where a lot of people get sort of hung up on with using script is finding the actual object they're after and to sort of retrieve it and interrogate it. A great little sort of tip, I suppose, is if you use the keyword choose, and then you can put in a class name, so which was Eve passcode util, I believe. Yep, and it returns an array of all the instances of that class. In this case, there's only one, so that's great. That's what we want. Let's create sort of a reference to it. You just pass in the memory address. And another little shortcut, rather than having to dick around with JavaScript to try and get all the instance variables. Actually, no. We know that the instance variable is called passcode, right? So pu.passcode, and you can see there's the passcode right there. So it's 2580. And yeah, sweet. So you can interrogate, you can list out all the instance variables in a particular object with this little sort of shortcut with the asterisk. So you can list all that out. And so you can see how you can kind of go spelunking, I suppose, through an app with script. You can also change things. For example, if you want to, I don't think this actually does anything, but if you wanted to change to should disable, that's the other great thing about script, tab completion. It's pretty cool. So if you want to change that to disable passcode after next unlock, yes or true, you just do that, and as you'll see, it's also got history too. It's pretty great. As you see, sort of, no, it hasn't changed. That's, whatever. So you can set variables like that. I know that doesn't do anything anyway. And yeah, so again, look for things like passwords, pins, credit cards. By nature, you'll have to load stuff into memory to actually use it and do stuff. So you always sort of see you look at for a logon view controller or something like that that will contain a password field that has the password variable. Where you get potentially hung up on tests, and unfortunately Evernote doesn't do this, is you'll do it once. You put in the password and you'll go and you'll find it, and you'll find the object in script, and you'll get it and you'll get the password. Oh, great, cool, I'm going to go show my colleague, my boss, whatever. You terminate the app, it logs you out, and you try to do it again, and it doesn't work. And you haven't put the password in, and it's well, hang on a second, where am I going to get the password? And that comes back to the basic OO principles, right? When you restart it, it would create, a new login view controller, a new instance of it, so that password hasn't been loaded into memory yet. So that's where a lot of people get hung up on. But again, it comes back to just this choose keyword. You just choose. You'll see multiple instances there, and you can just pick the ones and interrogate it. The object will likely still be in memory. Cool. So moving on, I'm conscious of the fact that we don't really have too much time.
About 10 minutes.
10 minutes. I've got a shitload more to go. All right, manipulating functions. So this is where it starts to get pretty cool. Objective-C can observe and modify its own behavior at runtime. You can call methods directly, modify functions, and even create your own classes and methods. Obvious security implications, right? So what can you do? You can break security checks, jailbreak checks, debug prevention, cert validation, bypass auth, and I'll demonstrate a few of these now. You can subvert business logic, or get the highest possible score in Flappy Bird. That's another thing you can do. So again, quick and dirty approach. You go back to the class dump, look for sensitive functions, and really where you get the quick wins and where you still see a lot of on iOS is simple logic. So you hook into the running application with script and then either call the functions directly or modify the function somehow to do what you want it to do. So I'll demonstrate an authentication bypass for Evernote. All right, cool. So you guys can see that. So yeah, so let me just pull up my notes in the interest of time. So, yeah, so the auth bypass. So an interesting thing when you're looking at an app cold, the first place to start typically is the app delegate. So here we go, the Eve app delegate, right? It's usually, it's kind of the entry point for the application. I mean, main's technically the entry point, but for all intents and purposes, that's where it is. A lot of like application-wide logic sits in the app delegate, so it's usually a good place to look for things. And immediately I see some interesting things here. I see a pin lock view controller, right? So that sounds interesting because going back to like simple MVC, you know, controller has the logic and you know, you've got logic for the pin view. I want to look at it. So, so what I do is I just take the class and go searching for it to see what we can do with it. And here we go, we find it. Let's look through some of the methods. It's got a class method to initialize it. And I saw something here last night that looked interesting. Dismiss pin lock animated. I wonder what that does, right? So let's go see what we can do here. So that was, so it was in the app delegate, right? So let's look at the app delegate and use the little asterisk. And we get all the information, but we can see here the pin lock view controller, right? So we've got this object here. So let's just let's create a reference to it. Pin lock VC. Cool. And what do we say the, so again, square brackets, let's just call it directly. Let's see what we can do. So PLVC was dismiss, pin lock, animated, right? It takes a parameter, and we can see from the class dump, right, it's expecting a Boolean value. So yes, which is in Objective-C, yes and no, it's true and false. And I'll bring up this. Hopefully this works. Hey, so there we go. I've bypassed the pin. So again, look for simple logic like that. It's rife with iOS, particularly in apps that have like offline authentication and offline client-side logic. And like, for example, I do a lot of testing of like board papers applications. So like directors, they don't want their big board pack. They want an iPad with all their board papers on it. But one of the use cases is they need to have it so that they can be on their business class flight with flight mode on, and they can't like authenticate against the server. So they need offline authentication, and they're rife for these vulnerabilities, just auth bypass everywhere. So cool. So that's that one. Let's get back onto it. Jailbreak detection. All right. So a quick caveat. I was trying to look for good examples for jailbreak detection because it's something that's practical. If you are testing apps, particularly high security apps, you know, you will come across this, and sometimes it might prevent you from actually doing further testing in the app. I would try to steer away from like banking apps, only because you know what the corporate overlords are like. I don't want to get sued. This is only for educational purposes. So be cool. So Pat, like, don't tweet that, you know, the mobile banking industry is, you know, going downhill. So let's have a look. So the app that we're looking at is with ANZ. Sorry, it's like a wealth management thing, and it comes up with this warning. I don't know if you can read that, but it says your device appears to be jailbroken. This is the case. We cannot guarantee the security, performance, or reliability of this device, which is fair enough. And a lot of banks actually do this as opposed to actually preventing you from running with on a jailbroken device, it's just like a click-through warning. So obviously that means we're jailbroken. We are running on a jailbroken device. So let's get rid of that. So let's go to the class dump for this. God, this screen is... there we go. Class dump backup. I think I have one for growth. Yeah, cool. So I won't bother with the syntax. So with this one, to save time, I found a couple of interesting things. In the app delegate, there's a method called warn user if device is jailbroken, and that's the method that gets called that returns that alert box, right? So it goes and checks a few other things. What it checks, what I found is a class called ANZ jailbreak detector, right? It has a couple of variables, an array of jailbreak file paths and symbolic paths. So they're just basically files that would exist on a jailbroken device. So pretty standard sort of file system check. And this is an interesting one, like, is device jailbroken? Returns yes or no. So if you're thinking like, if I want to warn a user, I would throw a pop-up if it's jailbroken. Maybe I call something that says, is device jailbroken? If it's yes, I might do it. If it's no, well, then I won't. So, so what we can do is, obviously we want to subvert this, right? So we can go, let's get rid of this. Let's run the app. And cool. So we'll hook into the running app. And I think it's called Grow. Cool. So in the interest of time, I'll just jump straight to the issue. So let's see. So yeah, cool. So I'll throw out some syntax here. Class was called ANZ jailbreak detector. Sorry, I need to make sure there's no spelling mistakes. Messages. Is device jail? I think it has broken. All right, cool. So, thank you. That would fail, and that would be embarrassing. Look, there we go. Sweet. All right, so basically what's this doing, so Objective-C uses message passing. So basically what that's saying is, for that class, find that message, which is the method, and change the implementation to that function, right? So again, trying to keep this practical. You don't really need to understand how it works, but if you're trying to change something, class, method, and what you want to change it to. 9 times out of 10 with simple logic, you're going to just want to change the return value, or just change it so it doesn't do anything. So we'll see if this works, hopefully. Come on. Sweet, that works. So what we can do now is, I'll bring this back up. So here, if we go to now and call UI app delegate, it was warn user device is jailbroken. You should see that it does nothing, right? Because it's calling that app and it's returning false. So it's actually saying, no, it's not jailbroken anymore. There are a whole bunch of other bypasses in that, but like that's a simple bypass by just subverting simple logic. And thinking about other things you can do, so there's a recent trend towards like PhoneGap or Cordova frameworks where you can kind of use HTML, CSS for your app, but they all have this method, eval.js, where it takes a string of JavaScript and executes it. So thinking about that, you can just hook into the runtime and just completely mess with the app. How much time do I have left?
Basically none.
Basically none. All right, cool. So I won't go through persistence. You can catch me afterwards. But basically, I was going to show how you can make it persistent. So like right now, if I like close out the app and get back into it, it will still show the warning because I've closed out the app. I'm not in the runtime. It's not modified anymore. But you can make it persistent. Why you do that? So like maybe you're preventing the use of the app, so you can just get rid of that. I'll put these slides up. That's the hooking. So just briefly, everybody knows what Swift is. Unfortunately, it complicates this a little bit. Uses the same runtime, but there's no dynamic dispatch, so it's harder to do the runtime manipulation. Wrong way. So it's harder to analyze. Can't do class dump. They mangle all the names, but you can still do some stuff. With the Objective-C bridge and objects, Swift objects can inherit from NS objects, so you can still do that. Limited hooking with mobile substrate. But look, if you want to analyze it, use a disassembler, class dump, and things
breathe,
like that.
Michael, breathe.
Questions?
Take a breath.
Sweet.
All right. So we're basically miraculously running on time at the moment. Questions are going to put us a little bit over, but that's okay because
would you prefer that I show like how to make it persistent or like answer questions? I don't mind.
What do people think? You guys want to see it?
Persistence,
oh, yeah!
Right. Demos.
Yeah! Can I get a yeah?
Sweet.
All right.
All right. So I skipped a bit of the slides. Let's screw that. So.
Ask dump backup.
Yeah. Cool. So basically, in the slides, you'll see a bit of setup around using a tool called Theos. Basically, it ports the build chain and has a bunch of different tools to other systems other than OS X. So you don't have to be an Apple fanboy to actually do this stuff. Hopefully this works. Cool. And it has a neat little menu. You can do it a sort of a more manual way, but I'm going through the easy way, so it's easy to use. We want tweak. So we do that. Project name, let's call jailbreak hook. Package name, I'm pretty sure it is au.com ANZ .grow. And basically what that tells the tweak is to make sure that it actually hooks into that package. Maintainer name, sorry, no, that's where I need to put it, anz.com. Fucking reverse DNS always gets me. Grow. And then just none. And then what that should do is you should see a folder, jailbreak hook, and it has a tweak file. So if you open up the tweak, you can see it has a bit of boilerplate, which is great. It helps you out. So basically, let's get rid of this. The class name to hook was ANZ jailbreak detector. In fact, I have one that I prepared earlier. That probably is quicker, right? Yeah, tweak backup. Actually, I don't. Adjust the tweaks. Never mind. It's just the tweaks. It's compiled tweak. Cool. So, and we don't need to hook a class method. It was an instance method. It didn't have any arguments. So here we use this sort of template. Basically, it returns bool. Remember, and it was is device jailbroken, and we just want it to return no. And this is where you always get tripped up. There's this little comment thing at the end, and it always screws you up. So you save that, and no, CrikeyCon is what's called jailbreak hook, right? Oh, it's in the class dump.
We're nearly there.
Yeah. It was called jailbreak hook. And then it's just a simple matter of, there's some environment variables you need to set, but that's all in the slides. It's just a matter of running make, and it should compile it. So And then on your device, I'll just use this one. It's nice and visual. There's a directory called under root library mobile substrate, dynamic libraries, and you put, go to my backup that I've already compiled. You just copy them across. So hopefully now.
Hopefully, here we go.
Yeah, so.
Are the gods smiling?
Hopefully.
Are the planets aligned?
Where did this
Can you tell us what you're feeling at this moment, Michael?
Dread. Okay, sweet. So if we get back into it, we'll just shut it down. And it should boot up, and it should hopefully not show the message. It doesn't show the message.
Persistence, yeah!
Persistence. So that's like a very basic example. You can do some really cool stuff. You can also hook the lower level frameworks, so like the NSURL session and stuff that handles requests, so you can hook in so it sends it to somewhere else, and then forwards the request on. You can hook the logging, the pasteboard, all that kind of stuff.
Okay,
so it's good.
It's okay. You can stop it.
It worked. It worked.
All right, so
Sweet.
we're going to allow like 1 or 2 questions, and then we're going to move on to the next talk, the final talk for the day. Does anyone have any questions, or would they like to do the right thing by the entire conference and ask Michael later?